Hello, sir. This is my presentation on a semiconductors laser for the alternative assessment tool in physics. So, my name is Arush Divedi from the EC department, and I'm from PL section. So, this is my introduction, and for next page. So, first comes that what is a laser? Laser is an acronym for light amplification by stimulated emission of radiation, and it is a highly monochromatic, coherent, and directional and a high intensity beam of light. Uh, there are many methods of how a laser can be created, and my topic is semiconductor lasers. But there are other methods of creating a laser that are solid state lasers. For an example, a laser which uses ruby to create laser radiations. Then we get gas lasers like helium neon lasers. We have chemical lasers which use highly concentrated chemicals to generate the effect of stimulated radiation and so on. Why did I choose semiconductor lasers? Because semiconductor lasers are really advantageous over other kinds of construction of lasers. And that is because semiconductor lasers, first, they are really efficient. So they are very efficient and they can go on for a very long time without getting damaged. They have a very high lifespan. They are compact and really lightweight, so that it can be really easy to use them. Next, we can control their output and their output type. So we can control how intense the beam has to be and how we want the laser, like in pulses or in a continuous beam. Next, it is really simple to design, and it's really cheap to create, and cooling technique which it incorporates is really easy to employ and does not cost much to us. Next, the beam quality is really high and good intensity of light is created in a semiconductor laser. Next, we have a principle of working. Semiconductor lasers are specially fabricated PM junction diodes and they are highly doped. They are meant to be used in forward bias modes, and when high current is passed through this PN junction and forward bias, what happens is that the electrons in N type and holes in P type come from conduction band and valence band towards the junction. And when they come towards the junction, they attract each other, and a combination happens. This emits a recombination radiation, and the radiations, the each photon's energy level is equal to the energy band gap of the semiconductor. So as you can see here, I have this formula. Eg is the energy gap of the conduction band and between the valence band, and h nu is the energy of the photon. Okay, so any laser semiconductor PN junction is fabricated so that the energy gap between the conduction band and valence band is according to the wavelength of the photons we need. Next, we have construction. So as I said that it is just a PN junction diode and much is not needed. So next, the semiconductor laser is made of different materials like gallium arsenide, indium phosphide, gallium nitride, etc. These materials are used for different photons and different wavelengths as per the need of the creator. Thus different kinds of lasers can be produced by incorporating different kinds of material. As for an example, if we want a red color beam, 640 nanometers, which is the general wavelength of a red color beam, we know the formula, and thus we get that the energy we need in electron volts is 1.94 electron volts. The gallium arsenide semiconductor lasers we have in markets come with a energy gap of around 1.92 electron volts, and thus it creates a red laser beam. As you can see, this is a big spot, while this is a very focused spot. So what is this? This focus spot is what we get through a semiconductor laser. This is the final product we want. But the semiconductor laser does not create a focused beam by its own. It incorporates an arrangement of lenses to do that, and without it, this will be the result. These are both pictures taken from 1 meter, and you can see the difference. This big oval kind of shape of green blob has a 10 centimeter of diameter, while this focused one has only zero point 0.5 centimeter diameter. So what happens is, first a convex lens is used. This is the convex lens is used to focus the coming radiations to the second focus of a concave lens, which then rearranges the light waves to be parallel, and thus we get a high intensity beam. Now we are here on to uses of semiconductor lasers. So in telecommunication, we know that optical fibers are really fast method of communication, and lasers are used as a method of transmission through optical fiber cables, as they can produce multiple kinds of wavelengths at a very high pulse rate. Next, laser shows are used as a purpose of entertainment for people. Lasers are also used as printing and imaging methods, like in laser printers and document scanners. Then, it is very advantageous to incorporate in defense, such as target designators and special op weapons, and also missiles which have a laser guidance system in them. Next, there are tumor and cataract surgeries which can be done by lasers without actually cutting anything inside the eye or the body, and it is really helpful, and it's really accurate. Next, we have material processing and manufacturing. So, lasers can also do welding, cutting, engraving, and all this can be done by semiconductor lasers, and there is no need of big lasers like chemical lasers or gas lasers. At last, we have sensing and detection. LiDAR just like a radar, but instead of radio waves, uses lasers, and this is, you can see here, can measure topography and many things like the ocean seabed, and it can be really helpful for different kinds of sensing and detection. Next, we have barcode scanners, as you can see, which helps us in daily life for fast and simple registration purpose in market or anywhere warehouses. So this was my presentation. Thank you. These are the references.